My name is Qiuyu,
My name is Emily Guan.
and today we're going to present Waxpaper Actuator, sequentially and conditionally programmable wax paper for morphing interfaces. Paper actuator has gained a lot of attention in each set field. It serves as the interaction design toolkits, actuating artifacts, soft robotics, and artistic expressions because it's inexpensive, biodegradable, and reusable. In addition, the technique to actuate those paper actuators has also been explored in the HSET field. For example, the global heating, local heating, and the pneumatic actuation. However, moisture, as one of the most important factors in natural and human world, has not been fully explored as the method and the way to actuate those paper actuators, and also the shape-changing interfaces. Moreover, the sequential control method for the shape-changing interfaces has not been fully explored as well. So here we are presenting the Waxpaper Actuator, a wax-printed shape-changing interfaces using grid levels and water mount for sequentially and conditionally programmable deformation and applications. And today we're going to introduce the deformation mechanism, fabrication strategies, sequential control method, and finally, the functional applications. Let's start with the video. Based on what we have learned in the video, we print the solid wax on the piece of paper, and it's going to form a bilayer structure with a wax layer and a paper substrate. And since wax layer is a hydrophobic layer and the paper layer is actually a hydrophilic layer, so when you spray water on both sides, only the paper side is going to absorb the water and expand. So it's going to push the paper to bend to the other direction. In order to fabricate these paper actuators, we go through from step 1 to step 3. First, we're gonna print the paper with the solid wax inkjet printer, and then we're gonna bake the printed sample into the oven for 300° F for 5 seconds. And finally, we're gonna laser cut the sample into the shape we designed. Based on all the things that we have learned above, we proposed a sequential control method for the wax paper actuator, which consists of the sequential control variables, the gray levels, and the water amount, and they're gonna determine the bending degrees and the bending speed as the dependent variables. So in terms of the water amount, we determine the water amount by putting it on different distances from the water sprays. It turns out that the more the water amount, the more the bending curvature is going to be, and the faster it's going to respond. As in terms of the second variable, gray levels, from the macro perspective, it's actually the different shades of the same color printed with the printer. From the micro perspective, it's actually a different density of the wax dots. So after the evaluation experiment, the higher the gray level is, the more it's going to bend and the faster it's going to respond. And based on those sequential control method, we did the geometry explorations, and based on the geometry explorations, we designed the primitive structures.
In addition, we introduced a computational simulation tool designed to replicate the bending behavior of wax paper actuators on basic shapes, along with its geometrical mechanism and walkthrough process. Utilizing Rhino 6 as the foundational design environment and harnessing the power of Grasshopper and Human UI as intermediate interfaces, the tool consists of 3 primary sessions: pattern selection, assignment of gray levels to each part of the pattern, and finally simulation to observe the sequential morphing of different sections. In terms of the geometrical mechanism, in the gray level experiment, we examined the relationship between gray level and curvature, and the correlation between gray level and speed. We find that the wax paper exhibits distinct bending curvature at specific times. Therefore, we computed for each gray level and find that the relationship between time and curvature conforms to a functional equation mentioned in the paper. Subsequently, we input the functional relationship into the curvature control module in Grasshopper. Ultimately, after users complete the pattern and gray level selections, they can observe the sequential bending process of the chosen pattern by adjusting the time slider.
So with the knowledge we learned from the sequential control method, geometry explorations, primitive structures, and the simulation tools, we proposed 4 applications. And the first one is the moisture-triggered natural seeding dispenser. So in this application, we print different shades of the gray levels on the same piece of paper. So it's going to form 2 regions: the tail region containing the soil and the seeding region where we put the seeds on. So when we put this actuator in the natural environment on a plant, for example, when the moisture is coming, for example, it's raining outside, the water is going to trigger the different regions of this actuator in different sequence. So the seed is going to be dropping on the ground, and then the soil is going to cover the seed. So it's going to gradually grow up as a plant, which saves a lot of human labors to the seeding process. And the second application is the morphing toys designed for the educational purpose and rapid prototyping purpose. And the third one is a lampshade for the home decorations. Besides the black and the white color of the wax, we can also customize the different colors make it more colorful. So in this one, we're making a lampshade for the home decoration purpose. And lastly, we combined the properties of the Waxpaper actuator with the electrical components. So here we made two switches, and the first one is the on switch. And when the paper was actuated, the region is going to absorb the water and then bend. So the copper tape on the top of the wax paper is going to be a part of the circuit. So it's going to be turned on. On the other side, the off switch is actually kept on all the time. But when it was actuated, it's going to break the circuit. So it's going to be turned off. So here is our wax paper actuator. Wax printed shape changing interfaces using gray levels and water amount for the sequentially and conditionally programmable deformation and applications. We introduced the deformation mechanism, fabrication strategies, sequential control method, and finally the applications. So we believe our wax paper actuator, coupled with the sequential control method, will benefit the HCI field and community through its low cost and simple fabrication process, as well as facilitating the rapid personal actuator customization. And that's it. Thank you very much.